Okay, for today's got a little bit of review of Chapter 9, and then we're going to go into some more problems where you have to prove by induction. So today is considered day 2 of induction. It's really mostly a review of yesterday, but let's start with this one. Do you get that I'd say n equals 1 to, does it like limit me on how many terms I have? Does it limit me? No, so therefore it's 1 to infinity. Raise your hand if you had that part right. Okay, so the sigma always starts with n equals 1. Always start with n equals 1. And then you say how many terms you have on the top, and it's infinite terms. And then you're supposed to use this formula. You'll have a formula sheet. And that formula goes right here, except what would be wrong with that? I didn't stick any numbers in. And all I'd be able to do is put in n equals 1, and I'd put a 1 right there, and I wouldn't be able to calculate it. So it's not really wrong. It's just that I should replace a with what? A is 7. And I should replace the r with, what is the r in this case? Yeah, you take that divided by that, which is 1/7, to the n minus 1. I need a variable in it so that I can take this and find the first term, and the second term, and the third term. Raise your hand if you set up that sigma properly. All right, that's less than half of you. We need to do another practice on that. I'm going to add a page here. So just try this one. If I had 8, and then I multiply by 1/4, I'd get a 2. And if I multiplied by 1/4, I get 2/4, also known as 1/2. Dot, dot, dot. And I'm going to say it goes on forever. Now, I did not ask you yet to add these all up. You could. Why could you? Well, because you can add up an infinite series like this if its r is less than 1, and this one's r is less than 1. Technically, you should say between 0 and 1. Okay, so, or technically between -1 and +1. But this one would work. It would qualify. You could find out the answer to this one. But I'm asking you to make a sigma for it, which means a summation. And I implied that this would go on forever because I had dot, dot, dot at the end. So try to do what I just did a second ago. It's just a repeat of the last problem. Make a sigma. That would work for this one. I want to get it up to like 80% of you getting right. Pausing. Okay. Did you say that it started with 1 and went to infinity because I didn't limit how many terms you had? Raise your hand if you had that right. Okay, good. Next, you need the a, which is 8, times the r, which is 2 divided by 8, also known as 1/4, to the n minus 1. Who all had it right this time? Good, we're up to 95%. Okay, so now, what's the answer? Remember, this is a problem. You just set up a problem. And the problem is, what if I needed to add this all up to infinity? So you made a problem. Now what's the answer to the problem? Use a different formula. I had it on the last slide. I know somebody in here knows it. For the people that can't remember it, I need a formula sheet. Raise your hand if you got this one. What do you think? You say it so quietly, it makes it sound like you don't know what you're talking about. Just say it a little louder like you mean it. That is correct. So if I'm going to use that formula, I'm going to just make some room for it here. Drag this over. A in this case is 8 over 1 minus r. Again, r comes from this divided by this, and it was 1/4. So 8 over 3/4, and flip it and multiply. 8 times 4/3, that's 24 divided by 3, which is, wait a minute, something's wrong. 32, there we go. 8 times 4 is 32 divided by 3. And that's a lot more logical because it was going to be 8 if I did it the way I said it. And I can't add up to 8. So what is 32/3? I don't know. It's almost 11. It's 10 2/3, I believe. Raise your hand if you got the same thing. Okay, good. Now, what if instead of adding to infinity, what if they just said, I only want this added up to the first 4 terms? Well, then I haven't got the right formula on the board yet. Here's the formula for that one. 1 minus r to the n over 1 minus r. But what else does it depend on? Think about it. A. Very good. So I need to throw in an a right here. Starting amount, of course, matters. So in this case, that would be a, which was 8, 1 minus r, which was 1/4, to the n, which was 4. I had 4 terms. All over 1 minus 1/4. So 1 minus 1/4 to the 4th. Ooh, that's a pain. 1 minus 1 over 4 to the 4th is 16 times 16. What's 16 times 16? 296 or something like that? 256? That sounds believable. All over 3/4. And yeah, that'd be a bit of a pain. This is the part where you'll have, double checking my memory on this, I think you'll have a calculator. If you didn't have a calculator, we'd have had to let you leave it like this, because nobody is expected to be able to do anything that complicated without a calculator. All right. I mean, you could. It would just take a lot of time. So, okay. There's our review of everything we've done so far. Now we're going to get into the new stuff that you've been doing lately, which is, I like this one the best, and it's actually part of your homework. So your homework is to do 3 problems like this. We will do this one completely together, and so it's part of your homework. So, do it with me right there on this slide, and you'll be doing your homework. Who remembers step 1? Let n equals 1. Everybody write that? And did it have to be 1? No, you could have let n equal 2 or 3 or 5. One of the things you need to understand is this is a list, though. And if you let n equal 1, you only have 1 term in your list. And it'll be the first one, which is 1. Now, you can stick it in here, and you'll see that it's 1. The main thing is that you don't think it's this plus this plus this plus 1. No, no, no. That whole left side is a list. And if you put in 1, you're getting the first term. If you put in 2, you're getting 2 terms. If you put in 3, then you're getting 3 terms. Okay, so if we put in 1, then this whole left side is a 1, and there isn't any more terms, just that first one. So 1 equals, and then n is 1, so I'm going to stick that in here. 1, 2 times 1 minus 1, and that's 1 equals 1 times 1, and then 1 equals 1. Yay, it worked. I proved it. So that's sticking in 1, making sure it works. All right, is that a strong proof? No, that's just kind of like, I think it works. Now, how do you go to the next level? Let n equal k, and that's actually an assumption step. We are going to assume it's okay to let n equal k. And you take your original formula here, and you copy it down, and wherever you see an n, you put a k. It's that simple. So 1 plus 5 plus 9 plus ... plus parentheses 4k minus 3 equals k instead of n to k minus 1. So all it is the same exact thing, easiest step in the world. You're just replacing an n with the k. Now you are expected to be able to set up this third step. But we understand that it is difficult enough that forcing you to be able to simplify this last step all the way to the end where it proves it might be beyond the scope of this course. This is like a college level thing. Okay, so we understand some of you could do it, some of you won't be able to do it. That means that it's not really a fair R3 question because it's that hard that we know a lot of people can't do it. So it's not really fair to make that a test question. But it could be an element of an R4 question. So being able to do this, don't think to yourself, I just heard him say, I'll never have to do this. No. The parts of this that are easy, you'll have to do, and that'd be like R2 or R3 stuff. The part that's hard, the end part, that won't be anything but an R4. Okay, so you got to do elements of this. The whole, all the way beginning to end, that would be an R4 level. Okay, so I'm going to replace part of this now with let n equal k plus 1. Now, a simplistic, like, oh, wherever there's a k, put a k plus 1, that doesn't work. Because the left side's a list. So I hope you're getting this, that the left side, 1 plus 5 plus 9 plus ... plus 4k minus 3 has to have something added to it. You don't put the k plus 1 in yet. You put it at the end. Plus, and again, you don't just slap a k plus 1 here. That wouldn't make sense. It was 4 times whatever k was. And we're replacing the k's with k plus 1. So this is 4 times k plus 1 minus 3. And that's just the left side. And that equals this side, except this side we do replace the k with k plus 1s. Up to there, we could expect you to do that. That's like you could be able to set this up like I just did. You have to be able to handle that for this next test. But the actual simplification part at the end, and again, I'm making it sound like it's impossible. It's not, but there will be several people that will not be able to pull this off, even after multiple tries. But let's see, with some guidance from you guys, I don't think this will be that bad. Who remembers on the left side, what big chunk can we replace with something else? Mr. G? All of that can be replaced with what? And if you don't see where he got that, it's right here. And I'll just circle it in red. It's right here. That's what says that that left side is equal to k times 2k minus 1. So I just replaced that with that. This part, keeping the same. And now, I will never touch the black writing. Remember, you can't mess with both sides. You can only mess with one side or the other. So I'm going to manipulate the left side until it finally looks like the right side. Do you remember last time it was all about if you can factor it, you should? Because like it's a really hard problem, and I've had that theme throughout this year. Like whenever it's a really hard problem, usually it just boils down to some complicated factoring. Well, it does again. So if you're looking for how do I factor that, you're on the right track. But you probably won't be able to see an easy answer. There isn't something that's like all factored by grouping and you can just factor something out. So what are you going to do? You still have to factor it. You know why I know we have to factor it? Because look at the answer I want. It's got a k plus 1 factored out in the front. It has to be factoring. So if it isn't obvious, what should you do? Yeah, say it louder. Distribute it. Distribute what? Distribute this. And distribute this. And then combine all the like terms together and see if you could factor that. And you can. Go ahead, multiply that all out, add it all up. You'll get something that's a quadratic, which can be factored. And then you'll really need to be creative at the end of this one. You'll get it factored. If you do this right, you'll get it factored, and you'll have a k plus 1. It'll factor out. You'll be like, ha, I'm really close. But not many people are going to be able to take this all the way. In fact, last hour it boiled down to just one kid who noticed, oh, I can replace this with this, and it'll work. So I'm going to let you try, because I don't want to take away the joy of like figuring it out if you can. So the only thing I've said so far is multiply it all out, add it all up, and then it'll factor. But at the very end, it'll take some creativity to do the last little factoring piece to make it exactly like what's in black. All right, I'm going to pause while you try that. Okay, so here's how you would do it. First of all, I suggested you multiply it all the way out, so we got 2k squared minus k plus 4k plus 4, and then a minus 3. And then I'm going to put that all together. 2k squared. My k's are getting weirder and weirder. Hold on. 2k squared plus 3k plus 1. That's not even that hard. That factors easily. But strategically, right now I usually write 2k, but since I know that regular k plus 1 is first, I'm going to put that first. K here and 2k there. Do you have to do it that way? No, you could reverse them in a later step. Okay, so then, well, what has to be here is a plus 1 and a plus 1, right? Because that's how you factor that. That's the only way to factor that. Raise your hand if you have it that far. Awesome. Now, here's the stroke of genius that you need to pull it off the rest of the way. So you look and see, well, I've already got that, and that's that, so I'm good so far. And I somehow need to get this to look like this. It'd be really nice if I could factor a 2 out somehow. So I overheard a kid say this in this room. They said, well, if you added 1 here, then you'd have a 2k plus 2, and then you could just subtract 1. Is it legal to add 1 and also subtract 1? It is. And now I've got k plus 1, and then 2k plus 2 minus 1. I know that seems weird to not put them all together, but see how this can factor now? Final answer, k plus 1, and the 2 gets factored out, k plus 1, and then minus 1. Another way to say it, a different kid in a different hour said, I'm going to break up this 1 into a 2 minus 1. You get how you could just jump right to a 2 right here? A 1 is the same as a 2 minus 1, isn't it? All right. So I know that's challenging. That's really hard. But in the end, I got what I was supposed to. I got this, which is it's exactly the same as right there. So yay, I've proven it. Did you get why this is not going to be an R3? Because that wouldn't be fair. Because most people get it wrong, and then you'd have to be perfect on everything else just to get an A, which is really hard to do. So, yes?
Would it be okay if you distribute out the last one?
I get what you're saying, but you want to mess with the right side, and you're not allowed to touch the right side. I know it's tempting to just like simplify this and then simplify that, but if you touch both sides, you're not proving it.
Like, what if you just like see what it comes out to be?
I get what you're saying. I get what you're saying. If you multiplied this all the way out and tried to figure out like what it would be, yes, that's not a bad idea to just like kind of like look into the future, but you still have to be able to do it over here. So if that helps you to do this, if multiplying this out helps you to do that, that's fine, but then you have to erase it, get it back to its original, you know what I mean? And then show the work here. But actually, what you just said is really smart. Multiplying this all out gives you an idea of what you could do in this zone, kind of like in reverse. It's sort of like seeing what you'd have to do backwards. Okay, yes?
So do you want us to end it saying, like, that it was
I would just bring this straight down here and say equals, and then it's identical on the left and the right, and then that's your end. You proved it. It's exactly the same. All right, I know those are tough. You have only 2 left for tonight's homework. This next one here, which is a tame one, relatively speaking, and that one there, a little more challenging, but not impossible. And on that very last one, this one with the green raptor on it, if you can just get to the setup stage, I'm okay with you stopping there. I've already said I don't think not that everybody can do this, but give it a try. Okay, so then for the rest of this hour, I'm just going to have you video a bouncing ball. Let me show you what I mean. We are going to bounce a ball from exactly 1 meter. You'll have to figure out where you want to put the ball at the top of the meter stick. Do you want it sitting above the meter stick, right in the middle, like the middle of the ball is equal to the top of the meter stick, or the top of the ball? You have to figure that out. So then you drop your meter stick so that it's 1 meter off, so the ball's 1 meter off the ground, and then you see how high the first 2 bounces go. The lab says 5 bounces. I found that that's almost impossible to get a video of the ball bouncing. In a perfect world, it would just bounce right in front of the meter stick, right? Almost impossible to get it to do that 5 times. If you get 2 bounces, 1 bounce, second bounce, and then you can stop at that point. Okay? So then, once you get it videoed, do you get that you can like zoom in and like see how high the ball is? Where it's ending? It started at a meter. Let's say it comes up to 0.7 meters. Now you can figure out your ratio. All right, so for today, you don't need to figure out everything. All you need to do is video the ball bouncing and twice. 2 bounces. You got to be able to see how high it came up on the first bounce and how high it came up on the second bounce, and then you can stop. Okay, that's all you need to do. Now, I don't want everybody to have to video it. So what I'm going to do is have you get in groups of 5, and you'll work together in that group of 5 to just video it with one person's iPad. And then that person can share it with the rest of you. I've had some kids share it on a Google Doc. I've had some kids share it by emailing it to everybody in the group. You can do that however you want. Okay? So, find your own group of 5, come up, grab a ruler, grab a ball, and then you can go in the hall if you want. One person videos it. Make sure you can look back at it and actually read it. And hint, be in a well-lit area. That's all I have for you for today.